Hi calculus students. Today we are going to be doing the derivative of inverse functions. So open your daily lessons to 92A and get ready to learn about derivatives of inverse functions. So hopefully you've paused me for a second and you're there. So what I need to tell you too is that in earlier courses you would have learned what inverses are, but I want to remind you of that because you've got other stuff going on in your lives, and I want to make sure that you know this. So f inverse of x, so written like f with a exponent of like a -1 to x, but it's not actually an exponent, it's just the notation saying f inverse of x numerically is defined to be the input and output switched. So you have a function and the x become y values and the y values become x values. So if I look at this on a graph, I can see the graph of the f inverse is a reflection of the graph over the line y equals x. So if you're thinking on a graph, y equals x looks here. So what's up here comes down. What's down here goes up, and vice versa. So we've got this reflection over the line y equals f. And if I'm talking about domain and range, the domain and range switch. So the domain becomes the range becomes the domain for f inverse. So if I am talking about, let's say, oh, I lost my paper. Where is it? There we go. I'm good. Okay, so the next thing, if I'm talking about an analytical representation of the inverse, what I mean by that is that if you write f and then I substitute its inverse, so I make this composite function and I say f of the f inverse of x, it will actually equal the same thing as if I said f inverse of f of x. So I've got f of f inverse, and I've got f inverse of f of x. And both of those things are just going to come out to x. So what I want you to do is take a really easy function. I'm going to take, I don't know, I'm making this up, y equals 2x plus 3. And so what I do is I'm going to switch my x and y's, or instead of this being y equals 2x plus 3, if I switch my x and y, and then I solve this again for y. So I'm going to say x minus 3 equals 2y, divide everything by 2. Y equals, what is this going to be? 1/2 x minus 3/2. Okay, so I do all this. This would be like f of x. This would be f inverse. Okay, so what I'm going to do, because I've got some room at the top of the page too, I'm going to go up here and I'm going to say, if I substitute 1 in, and I'm just going to do this one way, I can take f of f inverse. So if I'm talking about f of f inverse, what that really means is everywhere I see an x value, what I'm going to substitute instead is this whole function, f inverse. So I'm going to put in 1/2 x minus 3/2. So if I go over here and I'm thinking, okay, 2x plus 3. Instead of x, so 2x plus 3, I'm going to put in 1/2 x minus 3/2. I should have given myself more room, but you're smart and you can figure it out, and I just said it was minus 3/2. If I distribute this, I get x minus 3 plus 3. What do you know? There it is, it's x. That's just like we said. We could do it the other way too, but you get the idea that this is what it is, f of f inverse or f inverse of f of x, and you get x. So there is no calculus so far. It's just reminding you of something that you already know or you knew at one point. And so down here, there's two functions, f of x and g of x. And so you need to answer the questions that follow. So if I'm completing this table of values, and I know that the x and the y switch, or the domain and the range switch, if I can see right here, I've got -2, 3, and 1, 2, I'm just going to switch them around. I'm going to say, well, my x value now is 3, my y value is -2. My x value is 2, my y value is 1. So I'm just switching the x and the y values. Same thing with g of x. I would say instead of -2 and 1, I'm going to say this would be 1, -2, -2, 1, because these are my x values, these are my y values. And so this one's asking me to find f of g inverse of -2. And so the way that I do this is I'm going to say f g inverse of negative 2. So I could go over here and say, well, g inverse of negative 2 is 1. But if I didn't have that to look at, if I see g up here, I'm going to look at this and treat this like my x value and this like my y value. That's where this f of 1 is coming from. F of 1, I just do the old way. This is my f of x value. When x is 1, I get 2. So not so bad. In this problem, f inverse of f of 1, I'm working inside out, so I'm saying, okay, well, what is f of 1? F of 1, excuse me. F of 1 is 2. F inverse of 2. Okay, so I could just go up here and I said, well, 2 is 1. But I can also think, okay, f inverse of 2. That means like I'm treating this as my x value and this is my y value. Okay, I've got that this is 1. G inverse of f inverse of 2. Okay, a little bit harder, but I'm going to work inside out. So I'm thinking, what's f inverse of 2? Again, I can look up on this table and see that it's 1. Or I can go up here and I can say, okay, well, my x value would be 2 for f of x. What? Okay, this would be my y value. My f of x value, my function value for f of x is 2. The x value is 1, and I know those switch, so f inverse of 2 is 1. Now g inverse of 1, this is only g of x up here, so remember the x's and y switch, so I'm going to go look at 1, and I get negative 2. Or you can look at the chart we made. This one, in order for it to make sense, you have to change this to g inverse. And there's lots of things going on, but you're working right inside out first. So I've got g, and this is saying g inverse of 1. So I'm going up here, g inverse. So this is now my new x value. This is my y value. Or you can look at the chart we made and see that this is negative 2. Then I'm saying, well, g of negative 2. G of negative 2 would just be my x value is negative 2, my y value is 1. G inverse of 1. So here's my g value. So it's not g inverse, so I know the x's and y switch. This is my y, this is my x. So in this problem, this will be my x and this will be my y. And I get negative 2. Okay, so that's just reminding you derivatives has, well, it says derivatives of inverse functions, but it's really just reminding you what inverse functions are. So next page, so 92B. Here's when we start getting into fun stuff. And I realize that this is really hard to see, but you should have the same thing on yours, so you should be looking at yours also. Okay, so if I'm finding the derivative, so on the previous page we said f of f inverse of x, or f of f inverse equals x. And so we're gonna use that to figure out how to find the derivative. And so what I'm gonna do, you see how there's a function, f inverse is a function, and it's within a function? Wow. Seems like the chain rule to me. So what I'm gonna do is I'm gonna say, okay, well, even though there's an x on this side, I'm gonna take the derivative of both sides. So f of f inverse of x. Sorry. I'm gonna take the derivative of the outside, which would be f prime. And then you know what's next. We leave the inside alone. So I'm gonna treat this as f inverse of x times the derivative of the inside. And this is where it gets kind of messy because I'm dealing with -1 notation, but also like now I've got the derivative notation in here, but I'm still gonna say the derivative of the inside would just be like that. The derivative of f inverse. And then equals, and over on this right side, I still have x. The derivative of x is just 1. And so you think, great, that doesn't really help me in any way. But what I wanna do is I wanna figure out, well, what would happen if I got this by itself? So what I'm gonna do is I'm gonna divide on this side. I'm gonna do the same thing over here. and I know that you're probably excited where you are. Ooh, that doesn't look like division now, but it is. 1 divided by f prime of f inverse. Anything divided by itself is 1. What? Did we just get the formula? I believe so. If we want the derivative of an inverse functions, we take 1 over f prime of f inverse of x. And so another way that you can write this, I'm going to just write this over on the side. If I let f inverse of x equal g of x, because sometimes you'll see this too, that means f prime of g of x. So again, if I had this, I can write this up above. I didn't give myself enough room. It'd be like f of g of x equals x. If I took this derivative then, I'd say f prime, leave the inside alone, times the derivative of the inside equals 1, because the derivative of x is just 1. Divide both sides. So sometimes you'll see it like that too. Whichever way, I usually write it like this, but it's totally up to you. Okay, suppose that we have this function, and we've got what does this one say? It's really hard to see. F prime of -2 is 3. What's the value of f inverse of -4? But then I can see this prime, so I'm asking what is the derivative of f inverse at -4? And so I'm going to say f inverse of x. I know that it's the same thing as up here. The 1 over f prime of f inverse of x. And so what I'm going to do is I'm going to say, well, if I've got f inverse of -4 prime, the derivative, I would have 1 over f prime of f inverse of x, which in this case, we've got -4. So many brackets here. Okay, so the same thing. I know this is getting a little bit messy because I'm writing in a marker, but you know, bear with me. Okay, this one says f inverse of -4. So let's think about this. That if this is my function, f of x, this value is not going to be my x value. I'm not going to put this in and figure out what I get here for f inverse. What I'm going to do is I'm going to go over here and I'm going to say, okay, I've got -4. This is my y value for f of x. So -4 equals 3x plus 2. If I subtract 2 on both sides and divide, I would get x is equal to -2. Excuse me. F prime of -2 is right here because it was given to me. That's nice. So I get 1/3. Oops, started going into my other table. Not good. Okay, so I get 1/3. Woo! And then we had algebra, and now you're waiting for it. We have a table. Yay! Everybody's cheering. And so in this one, I've got f inverse of 3. And so what I want to do, if I've got f inverse, and I want to find the derivative, I know it's going to be 1 over f prime of f inverse of 3. And I'm going to look up in my chart and say, okay, well, what is that? If I've got f inverse of 3 and all I have up here is f of x, this is my y value. So if I come down here to 3, I can see that my x value for f of x was 1. And remember, for the inverse, they switch. So this is just going to be, this is my y value of 3. This is going to be my x value of 1 for f of x, so I switch them. So I get 1 over f prime of 1. F prime of 1, if I go up in my chart, this one is f prime. It's kind of hard to tell since I wrote over it, but that's f prime of 1 would be 2. So the slope of the tangent at x equals 3 for f inverse is 1/2. Okay, another one. You should try this too. Half the battle is just writing this correctly with the correct number of brackets. So I'm going to say 1 over G prime, you're working your way out, or you're starting in, you're working out. So G inverse of -2. Again, I don't have a G inverse on here, so I'm going to look and I'm going to treat my Y values like X's, my X values like Y's. So G inverse of -2, I see it's down here. So I'm going to go over my X, which is 1. 1 over G prime of 1. G prime of 1 was 1. That's nice how we used everything in that row. So the slope of the tangent is 1. Next. Oh, so sad, only one more to go. Okay, so 92C. And we've got more charts, yeah! Well, tables. We'll go with it. Okay, so it says up here that F and G are differentiable. Yes, that means that their inverses are also going to be differentiable. Sorry. And we have selected values for the first derivatives, F prime and G prime. Fantastic. So if I have a composite function with F and G, it's going to be differentiable too. So this one's saying find the value of the derivative of G inverse of 1. So I'm going to say G inverse of 1. This derivative is 1 over G of G inverse 1, which would be 1 over G prime. G inverse of 1, if I'm talking about G inverse, it's not on there, so I look at my Y values, which would be right here. This is at 1. My X value is 3, which means it would be switched for G inverse. 1 over G prime of 3. If I go to my X value of 3, G prime of 3 is -2. And you think, I found this value, woo, I did it. Then find the equation of the line tangent. Well, the equation of the line tangent, that's tricky, but I know that you're hoping we would do that. We've already got a slope of a tangent line. Now I need to figure out what point this is. And now it's a little bit hard because it's saying the graph of G inverse when X equals 1. Okay, so when X equals 1, this is talking about on the graph of G inverse. So I've only got G up here, so don't just say, oh, this is the point 1, -2. It's not. This is going to be the point 1, 3. Because this is my X value for G inverse, this is my Y value for G inverse, because remember they switched domain and range. Okay, the next one. Estimate the value of G prime of -1. So just because we've been doing something new doesn't mean you can forget what you knew before. If you're talking about G prime of -1, what that means, think about it in your head. If I say derivative, you think, I'm hoping you said slope of the tangent. So in this, so if I'm estimating this value, the only way I can estimate the slope of a tangent is to do the slope of a secant. So what I'm going to do is I'm going to say G prime of -1 would be G of -2 minus G of 0, because -1 is in between them, over -2 minus 0. And so in this one, I'm going to say, I'm just going to go up to my graph. G of -2 is 2 minus G of 0 is -3. So I get 1 over -2. And you're thinking, this has nothing to do with inverses. And I'd say, yep, you're right. If you put G prime, by the way, what you found was the slope of the slope. You don't want to do that. That's the second derivative. We want to estimate the first derivative. But we don't have to do everything about inverses just because you learned about them today. We want to go back and do old awesome stuff too. Because, you know, you're becoming even more awesome every day. Actually, you guys are all pretty awesome, and I think that right now, regardless of how much calculus you know, but shh, don't say that because I also want you to learn lots of calculus. Except, you know what I'm not awesome at, and you probably already caught this, 2 plus 3 is 5. Phew, that was a tough one, guys. I teach math. I'm good at my job. Okay, so I've got 5 over -2. So what does this say about the graph of G? Well, I can see G prime is negative. So G prime of -1 is less than 0. G of x is decreasing, you guessed it. And I'm going to say at x equals -1, because that's the only place that I'm pretty confident that it's decreasing. Okay, this one says estimate the value of G double prime of -1. The only way we can estimate the slope of a tangent is by doing the slope of the secant. But this one, if I'm doing G double prime, I'm actually going to do the thing I told you not to do last time. And say G prime of -2 minus G prime of 0. And then I can see G prime of -2 is 3. G prime of 0 is 2. And this one, as long as I subtracted correctly, yeah, I actually do get -1/2. And so this, what conclusion can be raised about the graph of G? Okay, this one's a little bit trickier. Because this was the second derivative, the conclusion that can be reached is that G of x is concave down at x equals -1. So concave down, remember, it kind of looks like the frown. It doesn't matter if the function is increasing or decreasing, but I'm saying that it's concave down. Looks like a frown. As G double prime. Whoa, guys, it's so late. I definitely just wrote but on my paper. Didn't mean that, and I'm definitely not going back and redoing this because I'm tired. Okay, as G double prime -1. Phew. Okay, guys, we did it. Apparently, the things we've learned is 2 + 3 is actually 5, and to not add extra letters when you're writing as. But if you made it this far and you heard me do all that, that means that you stuck with me through 22 minutes. Hopefully you skipped around, stopped when you needed to, and, you know, generally we're awesome. So, yeah, that's about it. Okay. I was going to say have a great night because it's really dark in my house and, you know, it's nighttime. But whatever you're doing, have a great day, morning, noon, night, whatever.